Hello, everyone, and welcome to Simplifying Windows Runtime Deployment in Kubernetes. My name is Muzz Imam. I work at Microsoft as a senior program manager on the Windows containers team. I have been a SIG-Windows contributor for some time. And with me is Michael. Michael, do you want to go ahead and introduce yourself?
Absolutely. Hi, everybody. Thank you, Muzz. My name is Michael. I'm one of the SIG-Windows co-chairs. I helped found the SIG and started a few years back. I'm also a director of product management at VMware, and you can find me on the Kubernetes Slack account under the alias M2. So let's take a look at the agenda that we're going to present today. Muzz and I are going to take you through a quick journey of where we are today and how we got here from a SIG-Windows perspective. We're going to talk a little bit about the continuous improvement that we're doing as a SIG, and then we're going to do a deep dive on the runtime for containers on Kubernetes with the Containerd update. We're going to talk a little bit about networking enhancements and finish it off with our roadmap and how you can contribute. This is the second presentation that we have on SIG-Windows. I highly encourage everyone to view the introduction to Windows containers that's on your program schedule for the KubeCon Cloud Native Con as well. Let's take a look at first our history and how Windows started. Our first release was 1.5. It was our alpha release, where essentially all we had was a kubelet and the kube proxy running on Windows, and kind of showed everybody the art of the possible. There were a lot of limitations here, but it kind of encouraged the community to come in and contribute on Windows in Kubernetes. With 1.9, we had our beta release, where we had significant advancements, including some initial CNI support. 1.14, that shipped a little bit over a year and 4 months ago, we had our first stable release. That means that we have supporting Windows containers on Windows Server 2019 nodes for production workloads on Kubernetes. Amazing stuff, like the community kind of banded together and got that release out. Since then, we've had 4 releases of Kubernetes, starting with 1.15, 1.16, and 1.17, where as a community, we made advancements in Kubeadm, CSI, run as username, volume support, and also added support for additional operating systems like Windows Server 1903. With 1.18, that was the release that came out about 4 months ago, we graduated to stable support GMSA, which stands for Group Managed Service Accounts, and run as username, to enable our users to be able to take advantage of Active Directory identities for Windows workloads in Kubernetes. We took Kubeadm to beta, Cluster API to alpha or experimental support, and then we also had the CSI proxy work in alpha and Containerd in alpha. That was a huge release. 1.18 was pretty much our biggest feature-rich release since 1.14 when we actually went GA. Now with 1.19, we're adding CSI proxy work to beta. Containerd is going to beta. So you can see we're having this gradual improvement and gradual moving of our support to an offering that gets better and better with every release. We're adding support for DSR and endpoint slices, so lots of networking improvements, and additional stability and performance improvements. So when you kind of think about this, our community is vibrant. We're executing a ton of changes across the board, from storage to networking to compute, and we're advancing the vision of Windows containers in Kubernetes with every release. In the next slide, we're going to have Muzz take you through a deep dive of Containerd and some of the work we're doing there.
Thank you, Michael. So let's take a look at Containerd and what progress we have made and why we are going the direction of Containerd. So the Containerd runtime provides a variety of benefits, and we're going to cover a little bit on why we're going in this direction. So basically, it aligns with the direction of the Kubernetes community, and Containerd is the runtime where we're actively community is investing. It's also optimized and maintained by the community, so it makes it easier to make additions, to fix bugs, and all that sort of work. The other thing that is a big benefit of Containerd was from a networking perspective, we were able to enable new CNI plugins. And the reason we were able to do that is Containerd is able to leverage fully the CNI, the guidance, and it adheres to it, which includes creating a new network namespace before invoking any plugin, for example, or the runtime must add must not add twice before deleting it, so you need to add it once. So those kind of things enabled us to support the new CNI plugins. We're going to talk about architecture, so I'm going to leave it there. We're going to deep dive into the architecture, but it's less monolithic than Docker. Some of the new features that we already are supporting today, and we were able to because of the Containerd, is especially, I'm going to go into the V2 schema in a bit, but basically the features that are today available in Containerd and not in Docker are single file mapping, for example, graceful shutdown of pods. We talked about the improved workflow of CNI and the true namespaces. So the other benefit, and a lot of benefit Containerd is getting, is because it's based on the HCS V2 schema. So when we started containers in 2016, Windows Server containers in 2016, back in there, this HCS, which is the host compute service, we started with a V1 schema. The reason we needed V1 schema is HCS actually handles both VMs and containers. And it accepts, instead of parameters, it accepts the JSON files. So initially, we came up with this schema, and as we got feedback, especially from Kubernetes, we improved that schema, and that became V2 schema. In particular, the support of pods and the HyperV. That was very particular feature that's added to V2 schema, but it has a bunch of benefits. And Containerd is based on V2 schema. That's why we are able to provide these new features. Now, the two things we are working now and are not available today is HyperV isolated containers, which we're going to talk about in a bit, and the GMSA support is another thing we are working on to enable in Containerd. So that would be the future benefits. But overall, we are aligned with the direction of the community. So with that, so now we know the benefits of the Containerd and the direction. Let's move to the next slide and take a little bit deep dive into the architecture. So let's start with the runtime architecture. The reason it's important to understand the runtime architecture, and specifically Containerd architecture, because the community is moving that way, as Michael just said, is that number one, if you are a Kubernetes developer or a user using Windows containers on Kubernetes, you probably want to know the whole stack, especially the runtime, the different pieces and components, how they fit together, how they flow. So if you found, if you are having an issue, which component, where it's coming from. Number two is when you know where it's coming from, you can go and get help against it. And we're going to go into that on how you can get support if you're running into issues. So let's look at the Docker runtime first. The majority of the Windows containers on Kubernetes implementations today are using Docker runtime. So in the Docker runtime, if you look from the left side, you have kubelet within the Kubernetes, and then you have Docker shim integrated into the kubelet. This Docker shim is basically a shim layer for Docker that helps kubelet talk to Docker, and it's basically a CRI interface for Docker. But it is within the kubelet. Now, the way the communication works is the kubelet is going to call through Docker shim Docker runtime, that's in the middle box, and then the Docker runtime is going to call the HCS, and the HCS is going to then create containers. The HCS is host compute service we just talked about. The one thing to note here is, although the V2 schema we developed very closely with the Docker Moby project and Containerd, both of them, Docker used V2 in experimental, but they're still using V1 schema. So that's another benefit you get in Containerd. We talked about in V2 schema, but the HCS you see here is using V1 schema for Docker runtime. Now, if we move to the Containerd, how that's different. So right off the bat, if you look at the left side, the kubelet no longer has that container runtime shim. So we decoupled it. and the cry is now part of the container D, the container runtime itself. So that helps, with faster development and all the benefits of decoupling. So now the kubelet is going to call container D using the cry API. Cry API is developed for mainly for Kubernetes, and it's enabled by default. It's optional to use cry API, but it's enabled by default. So, and we're going to go into more detail on how this works. But basically, it goes to cry, and then the cry is going to use container D to call HCS shim. So that's another improvement in container D overall flow. So HCS shim is basically an open source repo published by Microsoft, which is a shim around HCS. And it has a lot of runtime features. Basically, it's a Golang interface for HCS and has a lot of helper functions for HNS as well. And it is, it can be used to do a lot of runtime functions. So another thing in container D is we are able to fully leverage the features of HCS shim. So that's another decoupling right there. And then HCS shim is going to call to HCS. Now HCS is using v2 schema, and then HCS is going to create the containers. So that's the overall flow and the difference between the runtime. Now let's go deeper into the container D. So if I go to the next slide, let's just start with the process isolated containers, which is supported today. In Windows containers, the only container that's supported in Kubernetes today is the process isolated Windows containers. So if you look at this diagram, think of it as a VM or a physical host basically running Windows Server. On the bottom, you have the Windows kernel, and you have this red boundary, which we call the virtualization isolation boundary. It's also the security boundary. I'm going to talk in a bit about the security aspect of it as well. But let's look at the big picture, right? So the gray dotted lines, if you can see the gray boxes, there are two of them. On the left side is your root, or the host. Within Microsoft, we call it root silo. On the right side, you have the container. It's a fancy way of saying it's just a process isolated container. So those are the two boxes right here. Now, when how the flow works is, as you see on the top, kubelet usually, or cryctl if you're a developer and you want to debug Kubernetes without installing all the components. That's when you use cryctl. Both of them are going to call the cry API in container D. We just talked about it. Now, the major components within container D are container D API, which is very powerful. But for Kubernetes, we use cry API. The components that container D relies on are snapshot, the networking, and tasks. Now, if you look from container D, when we are going to talk to the operating system, right, to the Windows, there are three distinct paths going down. On the very left side, you have snapshots talking to Windows graph driver. Basically, snapshots is used to create images, to unpack different layers of images or pull images. So think of this Windows graph driver as the Windows layer management. So that piece. And a snapshot directly talks to it. Now, in the middle, you have networking, which provides API to talk to CNI plugin. And we just talked about them, the newer plugins and the improved plugins we were able to leverage in container D. That in turn talk to host network services. This middle path basically makes sure that HNS creates all the plumbing for networking behind the scenes for you, for your container. And on the very right side, you have the HCS shim, also called a container D shim. We just talked about HCS shim. So the cry API is going to go through the HCS shim to call into HCS. Now, once it gets to HCS in process isolated containers is the one that's going to create this silo or the container. Think of the container in Windows as an advanced job object, basically. So it creates that, that gray box on the right, the gray dotted lines. And once it's up, the service, the main interface between your application running on the container and to the operating system is SIG-exec service. So that's the service that talks to HCS. And if your container application needs to talk to Windows kernel or leverage some of the functions in the kernel, C exec services also calls directly to the libraries in kernel. So that's the flow for the process isolated containers. Now, the important thing to note here is if you are running multiple containers, right, process isolated containers, the left box is going to stay the same. The right box is going to multiply, right, as many as you want. But as you can see, the security boundary, the virtualization isolation boundary, it stays the same. So this the security boundary is the red dotted line, and that's important to keep in mind. Now let's take a look at HyperV isolated containers and the benefit it provides in terms of security. So if we go on to this architecture, so now the previous slide, what we were looking at the boxes, think of it that's on the left side now, and we're kind of zoomed out. So the flow basically stays the same. There is a slight difference in the workflow, and I'll talk about it in a bit. But basically here you have the hypervisor on the bottom, and the root has the kernel, and then on the right side, this red dotted line, we're calling wcow UVM. It's a fancy way of saying a lightweight virtual machine. It's a utility VM. So in Hyper-V container, behind the scenes, it creates this very lightweight utility virtual, the VM. And this VM is where the container is hosted. And that's why it provides the security boundary. As you can see, now if you have multiple Hyper-V containers, each one is within that security boundary. So the difference in the flow is it's exactly the same until you get to container D shim or the HCS shim. And the HCS shim actually is going to talk directly to the GCS. So it's going to spin up a new UVM when you ask for a new container. On the right side, that whole UVM is going to get started. And then the service that's going to talk to is GCS. In the previous workflow, we used to have the GCS talking to HCS, just like in process isolated containers. But now container D directly talks to GCS. And then GCS, from that point onward, within the UVM, you have the root, just like we saw before, and you have the container, right? And it's exact same flow. The C exec service is the main service within the Hyper-V container, and it talks to GCS, and GCS is basically managing the flow. So that's the architecture of process-isolated containers and Hyper-V containers. Now, one thing I wanted to talk about besides the security boundary is if you see on the right side, I have a legend which says ownership and support. And the reason I brought that up is, and I color coded is often we get questions on like, where, if we are having issues here, where should we go? So the answer is, if you're looking at the top, kubelet or cryctl, they both belong to the Kubernetes community. Most of you are already contributor. If you're not, we encourage you to become contributors. So you can go to the Kubernetes community for support for kubelet and cryctl. Now, if you go to the next layer, that's the green boxes, right? The container D, the CNI plugin, and container HCS shim. All three are open source as well. They have their own repo, and you can contribute. You can file issues. You can do PRs against the repo, and we encourage you to be involved in those as well. Now, the brown boxes on the bottom, basically all those components are owned by Microsoft, and the Windows teams maintains them. And we're very excited to tell you that recently we launched a new GitHub repo. It's basically Microsoft/Windows containers. And if you go there, you can file issues. If you're having any issues from one of these components, you can file issues, and the Windows team triages them and gets back to you and fixes them. And if needed, they can even backport it to the earlier versions. So that's a little bit of support model and architecture. And if you have any question, I'm happy to answer it in the Q&A section. So let's move on to the next slide, and I will hand it back to Michael.
Thank you, Muzz. By the way, this has been super exciting. Thank you for the drill down into Container D. I think that it's super beneficial for everybody to understand all the different moving pieces, what's supported by whom, and kind of also see the tremendous effort that has happened out of our community with contributions from Docker and Microsoft and other contributors to actually make this a reality. It's a huge effort. It's been going on for months now, and I'm super excited to actually see that work coming to beta right now, where we're signaling that we're on a good path to a stable support at some point in the near future. So let's take a look at our technology matrix really quickly here. When we started with 1.14, our first GA support of containers running Windows in Kubernetes, we only supported one operating system, and that was Windows Server 2019. And what LTSC stands for in the legend is the long-term servicing channel that Microsoft is providing. That's the operating system that's going to be supported for a number of years. And the URL at the bottom indicates the support stands for Microsoft, including extended support options that you can purchase. So earlier, when Muzz was talking about the blue components, actually the gold components or brown being Microsoft, that's what Microsoft is supporting. You buy a support agreement, you get the OS support, and that includes a lot of the components that are at the infrastructure layer of Windows containers. The second type of support that we have is the SAC or SAC, and it stands for Semi-Annual Servicing Channel. And our goal from a Kubernetes community has been to support one long-term servicing channel and two additional SAC channels from Microsoft, most likely the two most recent ones. So we started with Windows Server version 1903, which is no longer supported now by the Kubernetes community. And with version 119, we're supporting three operating systems: the long-term Windows Server 2019, the SAC 1909, and the SAC 2004 that was just released recently a few months ago. Muzz, how about the containerd support? What does that look like?
Sure. So yeah, it's really exciting, and I love your excitement about the containerd and the improvement in the overall Kubernetes for Windows. So in containerd support, we started with alpha support in version 118, and the containerd version was 1.4. That's when we started supporting in alpha stage. Of course, we tested it on 2019, the LTSC you just talked about. And recently, we're super excited that, as you said, containerd graduated to beta. The thing to call out is it's without HyperV for now, and it's in 119. Again, the containerd version stays the same. It's 1.4. The last row is our aspirations. That's why I put tentative there. So we want to go GA with containerd support for Windows containers on Kubernetes with HyperV and GMSA. And we are planning to do it at 120, the Kubernetes version. The containerd version is probably going to be 1.5. And the Windows release, as just Michael, you said, we are going to test it and support it for the latest LTSC, which is 2019, and the latest two SAC for now are 1909 and 2004. With that, I think, Michael, you want to talk about networking.
Yeah, absolutely. Thank you, Muzz. So let's take a look at some of our networking enhancements here. So in addition to compute and storage, we also have networking work that's going on. And I want to call out that some of our storage enhancements around CSI, we're talking about those in our Intro to Windows Containers session that we have. So from a networking standpoint, we've seen that the tremendous effort around the Kubernetes community to support dual stack IPv6. So it's not IPv6 only support, it's dual stack. And we now support it on Windows as well. So you're going to see that as Kubernetes is getting more and more features out, our goal as a SIG-Windows community is to make sure that we provide adequate support for those features for the Windows containers community. Some other improvements to Kubernetes services: endpoint slices. Endpoint slices are amazing. Basically, what an endpoint slice is, it allows you to reference a set of networking endpoints and kind of act as a source of truth. Like endpoint slices is how we route internal traffic in Kubernetes. So when you enable endpoint slices, and with the support that we have now in Windows, you're essentially providing a performance improvement so we can support services with a large number of endpoints efficiently. This is great. We can have that large number of endpoints. And more importantly, with the next set of support that we have, which is DSR, now we support you to scale to a large number of services efficiently. So two things: scale to a large number of services and scale to a large number of endpoints per service. So great. We're at the support for session affinity. So a lot of customers and users call sticky sessions. We have dynamic IP preservation now. We have local routed VIP features, so we can support local node port access from host pods. And Antrea, which is, or Project Antrea, which is based on OVS, is a CNI, a networking plugin for Kubernetes, just shipped version 0.8.0, which includes full Windows support, including support for network policies. So a lot of great work has happened on the networking world from a Windows plus Kubernetes standpoint. In the future, 1.20 or later, we want to support CAN IP preservation when you have external traffic policy, and then as well as IPv6 support in CNI plugins. So think of those as key features that the community and users have asked for, and we're going to look to support them as well. When we kind of look at our roadmap, we're going to continue investing in the same areas that you heard so far. Containerd, we're going to add support for HyperV, we're going to add support for GPUs. We want to continue our investments in deployment and lifecycle management. So you're going to see Kubeadm, cluster API investments, and then storage and backup and recovery. We want to promote the CSI work to stable along with the Containerd work that we're doing. We want to add more storage providers. We want to light up Velero support with CSI snapshots so you can back up and recover your Windows containers on Kubernetes, as well as deprecate some of the in-tree storage plugins that are no longer going to be useful once we actually fully migrate to the CSI model. How you can contribute? Join our weekly meetings, view recorded presentations, help us write additional documentation and user stories, find bugs, fix bugs. We have a lot of bugs that are marked as good first issues, so you can help you get started with the minimal amount of knowledge on SIG-Windows. And obviously, like Muzz mentioned earlier, if you have bugs that are on Windows with any of the infrastructure and related work that Microsoft is doing, follow the website that Muzz mentioned to go to file feature requests or bugs, and the community around the Microsoft ecosystem is going to help you there. If you're going to reach us as a Windows community, we're on Slack, we're on mailing lists, we have our documentation, our GitHub repo, we have a YouTube playlist, and community meetings that happen every week. On the left, we have the co-chairs as well as the technical leads for the project. Feel free to reach any of us either on Slack or GitHub. Muzz and I would like to thank you for attending our session, and we're going to open this up for Q&A right now.
Yes, thank you, everyone. And we're happy to hear any Q&A you have.
Hello, everybody. And please post your questions on the Q&A with speaker box that's on your screen. If we run out of time, we can continue the conversation on Slack. So if you go to the CNCF Slack under 2-Kubicon-maintainer, there's a new thread that was created a few minutes ago for the for this specific presentation. So you can also ask questions there offline or throughout the day. We'll try to monitor it. You can call out either me or Muzz. That way we get the notification as well if you like.
That's right. Yeah, we're happy to answer any questions you have about anything we talked about, or maybe something we haven't talked about.
We're also encouraging folks to attend the other SIG-Windows presentation that's on the schedule. So it's if you want to learn more about additional areas on SIG-Windows, like our CSI support and some of the other work we're doing around improvements around networking and storage, we're highly encouraged. That presentation is tomorrow. I'm trying to find the time. It's tomorrow at 10 a.m. Central. So at 6 hours for European time zones, I guess. Given that there are no questions, the team here is mentioning to us that they might end the webcast. Please, if anybody have any questions, Muzz and I are more than happy to answer it. Thank you all for spending time with us to learn about Windows. But if you think something off later on, just find us on Slack, Also, as we've shown on the previous slide, I'm going to go to this slide again. These are the various ways that you can interact with the Windows community. Find us on the Kubernetes Slack, find us on mailing lists. You can attend our community meetings or view previous meetings on YouTube. We are very diligent about recording everything that the Windows community is doing.
Yeah, and there's, as Michael, you were saying, there is a really exciting stuff going on, especially like, it has picked up pace. For example, the privileged container stuff for Windows, we're looking into that. There is a lot of amazing stuff about CSI and others that are going on.
Absolutely, and even yesterday, James, one of our contributors from Microsoft, just submitted a proposal for introducing cluster API work for Windows. So anyone that's interested in a programmatic API declarative way of provisioning clusters and getting them up and running with some impact on Windows, that's a great area to come in and contribute and learn on a hot area of Kubernetes, which is cluster API.
Yeah.
All right. Well, thank you all. Have a great rest of your day. Enjoy the conference, and thank you for spending time with us.
Thank you, folks.